Hello friends, today we will discuss very important lesson in electrochemistry, that is electrochemical cell. We know in electrochemistry, this branch of chemistry which deals with the study of chemical energy and electrical energy, and how these two types of energy are interconvertible. Chemical energy, how it will be converted to electrical energy, and how electrical energy will be converted to chemical energy. So this is the main principle of this chapter, that it involves the interconversion of chemical energy to electrical energy. So first let us discuss what is electrochemical cell. This device which convert chemical energy to electrical energy. Chemical energy to electrical energy, this is called electrochemical cell. This is called electrochemical cell, which convert chemical energy to electrical energy. But reverse, what is that? Electrical energy to chemical energy, that is called electrolytic cell. This is called electrolytic cell. Electrolytic cell which convert electrical energy to chemical energy. In particularly in electrochemical cell, cell means every cell has two electrodes. One is anode, another is cathode. Cell means it has two electrodes, anode and cathode, and the cell contains particular electrolyte which conduct electricity. Medium, through particular medium electricity conduct. If you see the electrochemical cell, it is also called as, this electrochemical cell also called as galvanic cell. Galvanic cell or voltaic cell. Voltaic cell. Galvanic cell or voltaic cell. The special type of galvanic cell, which is electrochemical cell, is called Daniell cell. Taken as a Daniell cell. Special kind of galvanic cell. Special type of electrochemical cell is called Daniell cell. And this Daniell cell, if you see the diagram, the construction of which cell, Daniell cell or galvanic cell, look at the diagram. First you see left side always taken as anode and the right side is taken as cathode. And here left side is a vessel, a container containing zinc sulfate solution. Zinc sulfate solution, where zinc sulfate solution is dipped and Here zinc sulfate solution, zinc rod is dipped. Then your cathode is made of copper rod, which is dipped in copper sulfate solution of concentration 1 m, and zinc sulfate also contain 1 m concentration, and both container joined by salt bridge. Salt bridge, the U-shaped tube containing strong electrolyte in the tube, which maintain electrical neutrality between these two cells and close the circuit. These are the two importance of the salt bridge. Salt bridge, what is the role of salt bridge? It maintains electrical neutrality. That means in both vessel, the total charge remaining same. In this, suppose in the left side vessel, the total charge remaining same. In the right side vessel, the total charge remaining same throughout the reaction. That's why it maintains electrical neutrality, and it also closing the circuit so that electron can flow easily. This is the main role of salt bridge. And these two rods connected to the galvanometer or voltmeter. Galvanometer is the instrument which identify the low current. Voltmeter or millivoltmeter instrument you can fit, or ammeter you can fit to measure the current. But as the current is very low, so a galvanometer can be used. So this type of arrangement is called Daniell cell. And these two complete cell is called mixture of two half cell. This is called one half cell, and this is also one half cell. It is one half cell, it is also half cell. Both half cell combine to produce a complete cell is called Daniell cell. Here in this Daniell cell, here it is a copper plate, and it is zinc plate, and this vessel acts as a anode, and this vessel acts as a cathode. So this is one half cell, this is another half cell, this is your galvanometer, and this is acts as a salt bridge. What is salt bridge? Here you, instead of tube, you can use a piece of paper soaked with potassium chloride or potassium nitrate solution, which are very strong electrolytes. So copper sulfate solution where copper rod is dipped, zinc sulfate solution where zinc rod is dipped, which contain 1 molar concentration of solution, and both are taken in separate vessel. Some cases it can be taken in one vessel, but arrangement is different. So what are this is the construction, and what are the function? What is the function of your Daniell cell or this type of electrochemical cell? Here function is, if you see, before that you see the notation. How can you represent the cell? The cell can be represented first, left side is your anode and right side is your cathode. Here zinc rod is a solid and dip in zinc sulfate solution, means zinc ion concentration is 1 m. Then this is your salt bridge. As it is a salt bridge, so salt bridge symbol is, notation is double parallel line, and the second half cell, that is called copper half cell, that is your copper ion of 1 m concentration and in which copper rod is dipped. So this is the representation of Daniell cell. This is one half cell and this is one another half cell. And this part is called anodic part and this part is called cathode. Mainly zinc is anode and copper is cathode. This is the representation. Then the reaction. How the reaction takes place? Here the reaction depends upon potential difference. We know as it is a electrochemical cell which produces electric current. That is flow of electron takes place. Flow of electron takes place. One electrode produces electron and other electrode receive the electrons. So this is the difference. One producing electron, other receiving that electron. Here, as zinc is more reactive than copper, as zinc is a more reactive metal than copper, then what happens? Zinc gets oxidized. Zinc gets oxidized to Zn2 plus ion, and this Zn2 plus ion dissolve in water. After produced from zinc rod, it will dissolve in aqueous medium and releasing 2 electrons. These 2 electrons produced from zinc rod will remain in the zinc rod. It will remain in the zinc rod. When electron will be produced from zinc, then it remains in the zinc rod, but zinc ion will be separated from zinc rod. So zinc ion will be separated from the zinc rod and dissolved in the solution. That electron produced by the zinc will move through the copper wire and it will be taken by copper ion in the cathode. In the cathodic half cell, in the copper half cell where copper ion is available, that copper ion accepts the electron produced from the zinc. So what happens? This zinc 2 plus gains 2 electron, copper 2 plus gains 2 electron, changes to copper. If you combine these two, what you will get? Ultimately, what you will get the result? And the zinc plus copper 2 plus in aqueous convert to Zn2 plus copper. This is aqueous, this is solid. So what happens? Copper will be deposited at the where? Deposited at the copper rod. So the copper ion from the copper sulfate solution gets reduced to copper. So here copper ion is reduced, that is reduction. This is called, first one is oxidation. So as it is an oxidation reduction takes place, so the electrochemical cell, in electrochemical cell redox reaction takes place. In electrochemical cell a redox reaction takes place. Redox reaction takes place. One is oxidation, another is oxidation. Which electrode is oxidized? Here zinc is oxidized because zinc is more reactive than copper. The more reactive metal gets oxidized and the less reactive metal gets reduced. Here copper ion is reduced and the zinc is oxidized. So this is the final reaction of which one? Daniell cell. During during the chemical change, here chemical change is what? Zinc is converted to zinc ion and copper ion is converted to copper. Oxidation and reduction. This change takes place due to flow of electron from zinc to copper. Electron flow from zinc to copper, but current flow opposite direction. This is your current flow. But it is measured the voltage produced by this type of arrangement having 1 molar concentration of copper sulfate and 1 molar concentration of zinc sulfate ion. If you take, the voltage will be 1.1 volt will produce. How much voltage will be obtained? 1.1 voltage generally obtained in the where? Obtained from the cell. From this cell, 1.1 voltage is produced. This voltage, where here as this reaction, copper half cell and zinc half cell and copper half cell are joined, this change may be reversible. It may be a reversible change. Which one? This electrochemical change may be reversible. Reversible means reverse reaction, reverse current can be produced. Current generally produced from copper to zinc and electron flow from zinc to copper. But this can be changed if use external voltage. If use some external voltage here, if use some external voltage means what happens? You connect this electrode by extra source, some higher voltage you apply. Then very important is if external voltage symbol is E, voltage symbol is generally E. If external voltage is greater than, less than, if it will be less than 1.1 volt, if external voltage applied is 1.1 volt, then current, that electron flow flows from zinc to copper. Is very important. If the external voltage is less than 1.1 voltage, then electron flows from zinc to copper. If external voltage is greater than 1.1 volt, if voltage will be more than 1.1 voltage, then electron flows from copper to zinc. So it is a reversible change. By changing the voltage, reaction can be reversed. The change will be reversed. If external voltage is equal to 1.1 volt, if same voltage will be used in external circuit, then what happens? There will be no flow of current. No current is obtained. Case 1, case 2, case 3. First case, second case, third case. It depends upon the external voltage. So, every electrochemical cell has two types of potential. Every electrochemical cell has two types of potential. An electrochemical cell has two potential. What is that? One potential is called cell potential. Cell has two types of potential. That is called cell potential. Cell potential means when both electrodes is connected, close. Cell potential is obtained, or this is called potential difference. This is called also potential difference. Cell potential is called potential difference when both half cell is connected. When both half cells are connected. This is very important. When they will be joined, these both rod will be joined, that voltage will be produced due to the difference in potential of these, because one is more reactive, other is less reactive. So there will be a potential difference. More reactive, less reactive. That potential difference is obtained in the voltmeter. If you fit the voltmeter, you will measure the potential difference. That potential difference is called cell potential. But second case, before connecting, each cell, each half cell, each electrode has potential. Every cell, every half cell, it has also potential. It is already measured. This potential is called standard electrode potential. The potential measured for each electrode in standard state, that is called standard electrode potential. That is called standard electrode potential. Is expressed as E naught. Expressed as E naught. So every half cell has E naught value. What is E naught value? Standard electrode potential. Standard means condition is your 1m concentration and 25 degree Celsius and 1 atm pressure. Atmospheric pressure is 1 atm, concentration of the solution is 1 m, and the temperature of the medium is 25 Celsius. If you use this, that potential is measured for the particular half cell or particular electrode is called standard electrode potential. So every electrode has a standard electrode potential. So cell potential is the actual potential obtained when the both electrode will be connected. When both will be in closed circuit, that potential is obtained in the voltmeter. That is called your cell potential. But before connection, what is the actual difference? What is the actual difference? How much potential is between the two electrodes? That is called electromotive force, EMF. That is called EMF, electromotive force. Electromotive force. That electromotive force is equal to written as E naught cell. That is called E naught cell. What is the meaning of E naught cell? E naught cell means, what is that? E naught cell is equal to that is called E naught cell. E naught cell is equal to electromotive force of that cell is equal to higher potential minus lower potential. It is always E of cathode minus E naught of cathode minus E naught of anode. Why E cathode minus E anode? Because the cathode has higher tendency to accept electron. The potential of cathode is more. The tendency to accept electron is more. That's why E cathode minus E anode. E cell, that electromotive force is equal to E naught of cathode minus E naught of anode. Always it is written as E cathode minus E anode. That is a what? Designation, representation. Always you E naught of cell, EMF of cell is calculated, that is E naught cell minus E naught cell of cathode minus E net cell of anode. Always calculated because E naught of cathode is greater than E naught of anode. That potential is called electromotive force, EMF. But once it will be connected, when it will be connected, that potential will be obtained. That is called cell potential, or that is called potential difference. Cell potential and EMF will not be same because due to the nature of wire used, because wire has resistance, that's why the voltage may be less. That's why EMF is the value when electrodes are in open, not closed, and the potential difference is obtained when the two half cells are what? Close to each other, when it will be connected, closed circuit. This is called cell potential and this is called EMF. So this potential, generally electrode potential of cell, every electrode has electrode potential. Electrode potential are two types. One is oxidation potential, second one is your reduction potential. And oxidation potential is written as E naught OX and reduction potential written as E naught reduction potential. Oxidation potential means tendency to lose. Tendency to lose. That is called oxidation potential. Reduction potential means tendency to gain. Gain of electron reduction. So electrode has different nature. It may have higher tendency to gain or it may have lower tendency to gain compared to other. So potential are two types, that is oxidation potential, reduction potential. Generally we are using which potential for calculation? We are using a reduction potential. Always reduction potential is taken. Always the reduction potential is taken for calculation. Always reduction potential is taken for calculation. But remember, your E reduction potential is equal to minus of E naught of oxidation potential, opposite. If reduction potential of metal is known, then oxidation potential just minus sign. For example, the reduction potential of copper ion, or that is copper. Reduction potential of copper is plus 0.34 volt. Potential is measured as voltage. And what is the oxidation potential of copper? Will be minus. This is your reduction potential. If you take what will be oxidation potential of copper? Will be minus sign. But generally, always, which potential is taken? Always, reduction potential is taken for calculation. So, reduction potential and oxidation potential are in opposite sign. how it is measured? How the potential of unknown electrode is measured? The potential of unknown electrode is measured by knowing the potential of known electrode. What are the known electrode? Generally reference electrode and hydrogen electrode. Reference electrode taken for calculation of inert value. For calculation of inert value, generally hydrogen is taken as standard electrode. This is called reference electrode is taken as SHE, standard hydrogen electrode. SHE full form is standard hydrogen electrode. What is that electrode? Where the electrode diagram is just, it is a half shell, that a container containing HCl solution of 1 m HCl solution, where one tube is deep and the tube containing a platinum where one platinum foil is fixed at the end of the platinum wire. Then the side of the tube, hydrogen gas of 1 atm pressure is maintained, bubbling. Hydrogen gas of 1 atm pressure is maintained throughout the container, throughout the tube. Always 1 atm pressure is maintained, the constant pressure is maintained, and 1 m HCl is taken. This is a platinum where is used, and this is called half cell. This is a half cell. It is not a complete cell. Complete cell means it should be connected to another electrode. It is a hydrogen electrode, because only hydrogen is used. Hydrogen and H plus ion. So this electrode is called SHE, standard hydrogen electrode. What is the value of E naught? E naught value of that hydrogen is 0 volt. It is a reference. The value of standard electrode potential of hydrogen is taken as 0 volt. Standard value is 0 volt. So for calculation of reduction potential of any other electrode will be, when it will be connected to the hydrogen electrode, then that potential will get in the voltmeter. That will be the potential of the unknown electrode. For how can represent this one? Your hydrogen electrode can represent like this: platinum, H2 gas of 1 atm pressure and connected to which one? H plus ion of 1 m concentration. This is the half cell, that representation of, or the short form of the SHE. How standard hydrogen electron is represented. H2 is to H plus. This change indicates it is a anode. Where it will be used as a cathode. This is for anode. For cathode, the reaction is just opposite. H plus ion, then 1 m concentration, then H2 1 atm pressure connected to liquid. This type of change is called cathode. Because same electrode can be anode or can be cathode. It depends upon the oxidation. Anode means oxidation, remember, and cathode means reduction. So oxidation reduction reaction takes place if it will be used as either anode or cathode. When it will be connected to particular electrode, that voltage will be obtained. That is cell potential. When two half cells will be connected, that voltage will be obtained. That is called cell potential. That potential will be obtained E cell. That is, you cannot write maybe E cell or inert cell. will be equal to E naught of cathode minus E naught of anode. Means if cathode is a hydrogen electrode, look at here, if cathode is a hydrogen electrode, and this is, suppose this is your hydrogen electrode, this is your hydrogen electrode and this is your unknown electrode, then this potential will be obtained from the voltmeter. Then what is the value of E anode? You can calculate. If E anode is your cathode, E anode is hydrogen, then this is unknown, so can you calculate it? Because 1 is 0, it is always 0. So E of cell will be equal to what? E of cell will be equal to, suppose the cathode is your hydrogen, so 0 volt minus E naught of anode. Okay, so depends upon which one? Which one? The unknown electrode used, and the unknown electrode used should be it may, where it will be used in the with the connection with hydrogen electrode, its potential can be calculated by measuring the potential from the voltmeter, and that potential is called cell potential. That potential will not be calculated. It will be calculated from the voltmeter. Where it will be connected, that potential is observed, that is called cell potential, and that potential is equal to the potential of the unknown electrode, because 1 is 0. One potential is 0, other value that already you will get, that is the same value of the unknown electrode. This is the reference electrode. For reference electrode, always hydrogen SHE will be as a reference electrode. So like this, we can calculate the potential of unknown electrode using which one? The formula E naught cell is equal to E of cathode minus E of anode. Okay, thank you.